Alright guys, so we're going to continue on chapter 7 and we're going to review sections 1 and 2 by looking at some sample problems using graphing and substitution to solve linear systems. Alright, so let's look at question 1. Question 1 says the graph and equation represent two different linear equations. So they give us one equation, and for the other equation they give us a line. Okay, so from this line here we can write this equation, or we should be able to. All we need is the slope and the y-intercept. So if we're looking for the equation, we can write it in slope-intercept form. Y equals mx plus b. So we just need to find the slope and the y-intercept. So looking for the y-intercept, I see that it is -4. So my y-intercept is equal to -4. And my slope, if I do my rise over run for slope, if I go from this point to, I see it crosses right here on the grid also, my slope is +1/2. So I have a slope of up 1 over 2. So a slope of 1/2. So for this line here that they gave me, the equation would be y equals 1/2 x minus 4. Okay, there is two ways I could solve this. They gave me a graph with this equation already graphed on it. I went ahead and wrote the equation for it. But I could have, or I can, go ahead and graph both these lines and then see where they intersect and use that as my solution. Or, now that I have this equation written, I can use substitution and plug this in for y. So we're actually going to do it both ways. So first, let me solve this by using substitution. I'm going to substitute 1/2 x minus 4 in for y. So I'm going to rewrite this equation except for y. I'm going to put in 1/2 x minus 4. And I'm going to go ahead and copy down the rest of my equation here. So I have 2x minus 4y. So 2x minus 4y, which my y I use substitution, and then equals -12. Alright, next step from here is to distribute. So I'm going to distribute this -4 inside the parentheses. Okay, so over here in the front I still have this 2x. Okay, now when I distribute -4 times 1/2 x, I'm going to get -2x. And -4 times -4 is going to give me +16. And this is still equal to -12. Alright, if you guys remember, the next step is to combine like terms. So look right here, I have 2x minus 2x. So these are actually going to cancel each other out. And I'm going to get left with 16 is equal to -12. Now if you guys watched the 7.2 video, we talked about what this means when we get two numbers that don't equal each other. This means that our lines are actually going to be parallel and they won't cross. So if they don't cross, we won't have a solution. So we could go ahead and say no solution. I want to go ahead and rewrite this equation in slope-intercept form and graph it, so we can actually see that these lines are in fact parallel. So to solve this and put it in the form y equals mx plus b, we need to isolate y. And to do that, we're going to start by subtracting 2x from both sides. Actually, let me rewrite the equation over here and I'll solve it over here. Okay, like I said, we're going to subtract 2x from both sides. Do this in red. Okay, that's going to cancel this term out here. I'm going to get -4y is equal to -12 minus 2x. Okay, next step here, I want to cancel out this -4, and I do that by dividing by -4. Okay, negative 4y divided by negative 4. These negative 4's are going to cancel, and I'm going to get left with y equals negative 12 divided by negative 4 is going to give me a positive 3. And then negative 2 divided by negative 4 is going to give me a positive 1/2 x. Okay, the last step here to get this in slope-intercept form is just to switch this positive 3 and this positive 1/2 x. So I'm going to switch these, and so I'll be left with y equals 1/2 x and then plus 3. Okay, so looking at these two equations now, they do have the same slope, so I did confirm that they are parallel. And if I go ahead and graph this, let me try to get graph this in red. Okay, I have a y-intercept of 3 and a slope of up 1 over 2, up 1 over 2. Okay, going the other way, I would go down 1, back 2. Alright, so yeah, graphing it, we see that they're parallel, so we just solve this by graphing. We can see that they're parallel, so there would be no solution. And you could solve it by substitution. And we saw that we got two numbers that are not equal to each other, so that means no solution. Okay, question 3. We have a word problem here, and pretty much in these word problems 3, 4, 5, and 6 is we have to set up two equations, and then with those two equations we can solve them using substitution. So let's read what we have first. It says Austin and Josh have collected a total of 545 baseball cards. Austin has 50 baseball cards, more than twice the number of baseball cards that Josh has. Write a system of equations that can be found to find A, the number of baseball cards that Austin has, and J, the number of baseball cards that Josh has. Okay, so pretty much it tells us that it wants us to use, for Austin, it wants us to use the variable A, and for Josh, it wants us to use J. Okay, and these represent the number of baseball cards that they have. So if we look at this first piece of information, it says Austin and Josh have collected a total of 545 baseball cards. And if we're saying if A represents the number of cards that Austin has and J represents the number of cards that Josh has, well, if we add them together, this is suggesting that they have a total of 545. Okay, so we already have our first equation. If we add Austin's cards plus Josh's cards, we have a total of 545 baseball cards. Okay, now let's look at the second part of information. It says Austin has 50 baseball cards, more than twice the number of baseball cards that Josh has. Okay, so it says Austin has, so the number of cards that Austin has, what that is equal to, Austin has, is 50 baseball cards, more than twice the number of baseball cards Josh has. Okay, so if we take these number of baseball cards Josh has, Austin has twice the number of cards that Josh has. So we can multiply J times 2. And it also says that he has 50 baseball cards, more than twice the number. So plus 50. Okay, so Austin has 50 baseball cards, more than twice the number that Josh has. These are kind of tricky to write, but after we do a few of them, they'll start to make more sense. Now that we have two equations, we can use substitution to solve these. And this one actually is already solved for A. So let me rewrite these equations real quick. Okay, so with these two equations, I'm going to use substitution. And for A, I'm going to substitute 2J plus 50. So for A, I have 2J plus 50. Okay, and then plus j equals 545. Okay, next step here is to distribute. Since I don't have anything to really distribute, you could say I could distribute a 1, but that wouldn't change my equation. So I can go ahead and drop the parentheses and say 2j plus 50 plus j equals 545. Okay, from here I can go to combine like terms. So I have 1j plus 2j, so I have a total of 3j equals 545. Oh, left out the 50 here. So let's change this. $3j plus 50 equals 545. Okay, now I need to cancel out this plus 50, and I do that by subtracting 50 from both sides. That's going to cancel this out here. I get left with 3j equals 495. Okay, the last step here is to divide both sides by 3. And I'll get j equals 495 divided by 3. I'll let you figure this out. Once you figure out j, you can plug j back in here and solve for a. You could also plug it in here and solve for a. So I want you to find j and a for this one. Question 4 says, Sabrina works at a daycare for $8 per hour and at a local insurance agent's office for $10 per hour. Last week she worked a total of 15 hours and earned $134. Write a system of equations that can be used to find D, the total number of hours Sabrina worked at the daycare, and if I represents the total number of hours she worked at the insurance agent's office. Okay, so I went ahead and broke up these first two sentences. And it says Sabrina worked at a daycare for $8 per hour and at a local insurance agent's office for $10 per hour. The next sentence says last week she worked a total of 15 hours and earned $134. Okay, so if we know that D represents the number of hours she worked at the daycare, so let me highlight this information. Daycare is represented by D, and this is in number of hours for both. Okay, and at the local insurance agent's office, this is I, and this is number of hours. So with these two variables, I know she worked D amount of hours at the daycare, I amount of hours at the insurance office. So if I add these together, I could say that D plus I, the number of hours she worked at the daycare, plus the number of hours she worked at the insurance agent's office, is equal to 15, because she worked a total of 15 hours. Okay, so that's one equation. For our second equation, we know she earned a total of $134. So what she made was $134, and how much she got paid depends on how many hours she worked at the two different locations. So for the daycare, she got $8 per hour. So for $8 for every hour at the daycare, which is D. D represents the number of hours she worked at the daycare. And then we're going to add $10 per hour that she got paid at the insurance agent's office. So she got paid $10 for every hour at the insurance agency, which is represented by I. So this would be our second equation. So now we could solve this using substitution. here we would have to solve for one of our variables. We could solve for any of our variables, but it would actually be easier in this equation. Both of these have a coefficient of 1, so it wouldn't matter which one we did. I'm going to go ahead and solve for d. I'm going to subtract I from both sides. Okay, that's going to cancel out here. And I'm going to get left with d equals 15 minus I. Okay, so I'm going to rewrite these two equations up here, and then we're going to solve using substitution. Okay, so now we're going to substitute in our d, which is 15 minus I. Okay, so over here we still have this 8d. d we just replaced with what we knew d was equal to. Okay, we still have plus 10I equals 134. Okay, the next step here is to distribute. So I'm going to distribute this inside the parentheses. Okay, 8 times 15. I know 8 times 2, or I'm sorry, 15 times 2 is 30. So 30 times 4, that's going to be 120. Okay, 8 times negative I is going to give me negative 8I. Okay, we have plus 10I equals 134. Okay, next I can go ahead and combine my like terms. I have minus 8I plus 10I is going to give me positive 2I from these two. Okay, I still have this positive 120 here. So it's 120 plus 2I, just combining these two terms, and I have equals 134. Okay, from here I could subtract 120 from both sides. Alright, that's going to cancel out. I get left with 2I equals 14. Okay, I'll let you solve the rest for I. Once you figure out I, you need to substitute it back in. Substitute I back in. You can substitute it in here or over here and solve for d. It would be easier if you substitute it in here. This is an easier equation to solve for d. And I want you to get what d equals also. So this, our answer will tell us how many hours she worked at the daycare and at the insurance agency. Okay, question 5. The sum of the perimeters of two squares is 52 inches and their difference between their perimeters is 12 inches. If x represents the side length of the larger square and y represents the side length of the smaller square, write a system of equations that can be used to find the dimensions of the two squares. Okay, so this one's a little tricky just because they say that x represents the side length. It doesn't say it represents the perimeter of the small square. So x is the side length of the bigger square. Okay, so if we wanted to find the perimeter, we would have to add all four of those side lengths. So that would be the same as 4x for the perimeter of the big square. For the smaller square, it says it has a side length of y. So we'd have to add all four of those side lengths to get the perimeter. So the perimeter of the smaller square would be 4y. And we have a total the sum of the parameters, the sum of the two parameters. If I add these two parameters, I get a total of 52 inches. So this is how we would set up our first equation. The second part of information it gives us is, it says, and the difference between their parameters is 12 inches. Okay, so if we take these two parameters, the difference between them, difference means we subtract. Okay, so if we take the first parameter, the difference between this and the second parameter is equal to 12 inches. Okay, we have two equations now. We could solve one of these for y or x. Since we don't have a coefficient of 1 or -1 for any of these, it doesn't matter which one we do. I'm going to go ahead and do this one just so we have a smaller number once we use substitution. We have to distribute. Okay, so I'm going to solve for x, and I'm going to start by adding 4y to both sides. So I'm going to add 4y to both sides. This term is going to get canceled out, and I'm left with 4x equals 12 plus 4y. Okay, next step here is to divide by 4. And I kind of ran out of room, so I'm going to write it over here on the side. I'm going to get left with x equals 12 divided by 4 will give me 3, plus 4 divided by 4 is just going to give me 1, so I'm left with just y, 1y. Okay, so this is my equation here. Alright, for question 7, it says some values of two linear equations are shown in the tables below. Write a system of equations that could be used to find the solution of the system of equations represented in the tables. Okay, so I'm going to show you two ways that we can do this. There's actually three. If we use a calculator, we can do stat edit. But let's say you didn't have a calculator, so let's talk about the different ways we can solve this. Okay, so we have a bunch of different points. So if we want to write an equation, and normally when we think of equation we want to think of it in slope-intercept form. If we want to write an equation, we need to find the slope and the y-intercept. So we should know that you can find the slope using the slope formula. This is a slope formula, so I would pick 2 points. So for example, if I pick this point as my x1, this is my y1, this is my x2, this point as my y2. I would plug these in. I would find my slope. Once I found my slope, I'd plug my slope in and plug in a point into the point slope form, and I would get my equation. Once I solve this, I would get my equation in the form y equals mx plus b. So that's one way. So just to write this equation, just to give you an idea, my y1 in this case was 2, so I'd have y minus my y1, which is 2, equals, my slope is what I would have calculated, so let's just say m, x minus my x1 was 3, so x minus x1, which is 3. So with my slope, I would distribute my slope. After I distributed, I would add 2 to both sides, and I would get my answer. So if you don't have a calculator and can't do stat edit, I want you to try this method to find your equation. The other method we've done is, we know slope is just the rate of change, delta y over delta x. So if I see the change, so for example the change in y, if I go from -25 to -1, I'm adding 24. So my rate of change here is 24. Okay, so my change in y is 24. My change in x, going from -5 to 1, I'm going plus 6. Okay, so my change in x was 6. Okay, so reducing this now, 24 divided by 6 is going to give me 4. Okay, so I just found my slope, which was 4. Another way we've done this is just using the equation y equals mx plus b. If I know m and I know a point x and y, I just need to solve for b. So I just found my slope was 4, my rate of change was 4. So now I'm going to plug in a point, and I'm actually going to plug in this point right here just because it's smaller numbers, it's easier to deal with. So I'm going to use this for my x. So my x is 1 and my y is -1. Okay, so now solving this for b, I would have 4 times 1, which is 4, is equal to -1, and I still have this plus b. All I did here was multiply 4 times 1, which is 4. Okay, now to solve for b, I need to subtract 4 from both sides. And I would get b is equal to -5. Okay, so now I can rewrite my equation. Y equals m, which I found was 4. My slope was 4. X. And then my b is -5, so I can say -5. So this would be the equation for this set of points right here. I want you to go back and find the equation for this set of points. For questions 8 through 11, I want you to go back and watch video 7-2 if you're having any problems with these. But I went ahead and put the answers so you can check to see if you did them correctly. Question 12, we did one of these in class, but I'm going to help you set this one up and I'll let you solve it from there. So it says, challenge, find the value of a and b so that the linear system shown has a solution of 2, -4. Okay, so what they're saying is if it has a solution of 2, -4, that means when I plug this in for x and y, these will both be true. So I'm going to do exactly that. I'm going to plug these in for x and y. So for equation 1, I'm going to get a times x, which is 2, minus b times y, which is -4, and this equals 10. For my second equation, I have a times x, which is 2, plus b y, which is -4, equals -6. Okay, so next I'm going to simplify each of these expressions. 2 times a is going to give me 2a. Negative b times -4 is going to give me a positive 4b. And this is equal to 10. Okay, for the second equation, I'm going to multiply 2 times a. I'm going to get 2a. Now if I multiply b times -4, that's going to give me -4b. And this is equal to -6. Okay, from here you guys should be able to solve this using substitution. You have two equations. You need to solve for a variable. Once you solve for a variable, you can substitute that into the other equation and solve for your a and b. Alright, for question 13, it tells us that 3 lines given below form a triangle. Find the coordinates of the vertices of the triangle. The word vertices means the point where the corners of the triangles pretty much. So when we graph our 3 lines, this triangle that it forms, we want to find the location of the vertices, corners. Okay, so looking at the three equations they gave us, I'm going to go ahead and write what you should have got for each equation. Okay, check your equation, see if you got these same equations for each one. So you have your first one, second one, third one. These are the lines you're supposed to graph. Once you graph these, the points where they intersect is your solution.